So there are a lot of applications in computer science where you need to go for some kind of sorting. So there are some algorithms for sorting: selection sort, bubble sort, insertion sort, and testing sort. So we will be discussing at least first three: selection sort, bubble sort, and insertion sort in our course. So in selection sort, the concept is you have an unsorted array. Typically, we take the example that we have n number of elements in the array which are in unsorted form. So we have to pick up the smallest one from the entire array. So find out the smallest element from this unsorted and put it at the beginning of the array. That you can call as sorted. So take the smallest element from the unsorted part, pick it from there and put it in the beginning. Then now you have n-1 number of element. Search the entire unsorted element of n number one element. Now this unsorted part contains n-1 number of element. Pick the smallest one. Put it in the second position. Now you have n-2 number of elements. Find out the smallest element from this n-2. Pick it up, put it in the third position of the sorted part. Now you have n-3 elements. Find out the smallest one from there. Pick it and put it in the fourth position. Keep on continue this thing till all the elements from the unsorted part is exhausted. So the moment the unsorted part is exhausted, the sorted part will be filled up with n number of elements. So now the sorted part will contain the n number of elements which are in sorted order. So you can go for, if you go for ascending order, then try to find out the minimum from here. If you want to go for the descending order, to try to find out the maximum from it. So depending on your requirement, you can go for ascending order or descending order. For ascending order, find out the smallest one, then put it. If you go for descending order, find out the largest one, maximum one, and put it at the beginning. So this is the main concept of selection sort. So typically take an example. You have an array which is unsorted. The array contains 6 elements: 23, 78, 45, 8, 32, 56. So here the size of n is 6. So at the beginning, the unsorted part contains this 6 element. The sorted part contains 0, nothing. It is containing nothing. Pick the smallest one. We are going for ascending order. Pick the smallest one from this list. So the smallest one is the 8. Put it at the beginning and swap it to. So now the 23 becomes its position here, and 8 comes at the beginning, and 8 goes to the sorted part. Eight is in the sorted part. So there is a swap between this element and the smallest element. Now here you see, after the first part, the smallest element from the entire unsorted element, it comes at the beginning, and the unsorted part contains n minus 1 number of element, that is 5 element. 1, 2, 3, 4, 5 element. Do the same operations. Try to find out the minimum one. Try to find out the minimum one. The minimum one is 23. Swap 23 with the beginning of the unsorted. So 78 goes here and 23 comes here. Bring 23 in the sorted part. So now the sorted part contains 8 and 23. The sorted part contains 8 and 23. So out of the 6, there are 2 elements in the sorted part. So remaining n minus 2, that is 4 elements in the unsorted part. There are 4 elements, that is n minus 2 number of elements are in the unsorted part. Do the same operations again to find out the minimum from here. The minimum is 32. Minimum is 32. Pick that one. Swap it with the beginning. Sorry. Swap it with the beginning one. That is 23, 23 and 45. Swap them. Sorry. It goes to here and bring 32 at the beginning, the sorted part. So the new sorted part is this, which contains 8, 23, 32. See, the unsorted part contains 1 less, that is n minus 2. Now it becomes n minus 3. There are 3 elements in the unsorted part. Do the same operations. Pick up the minimum one. Pick up the minimum one. That is the 45. Swap it. 45 and 78. Bring the 45 in the sorted part. The 78 and 56. Do the same operations. Now there is only 1 remaining element. You don't need to do anything because that is the largest element. So it becomes sorted element. So typically, if you have if you have 6 elements, you need to go for 5 plus. If you have n elements, maximum you need to go for n minus 1 number of pass. Okay. Well, do you have any questions regarding this selection sort? Student, please.
Please interact with sir if there is any question.
Or what you can do, you can, I can give some example. You can draw it in your pen and paper if you want.
It is requested to everyone, please make interaction with sir. Because sir is asking something, so make interaction with sir.
It will be easy if you pick up any example of 5 or 6 element or 7 element in your copy and do this operation, and whether maximum n minus after n minus 1 number of pass you will get the sorted element. Or another example you can take, I have shown you in the sorted ascending order, you can go for the descending order. That instead of looking for the minimum one, you look for the maximum one. That is here, the maximum one is the 78. So bring it in the 78. Next, find out the maximum one. The maximum one is 56. Bring it in the second position. Like this way you can go. So if you want to do some kind of hands-on, you can go for that. Because writing the program will not be easy. It will take time. So I will not request that you write the program in a moment. But instead of do that, you can go for manual dry run. Take an example, you can go for dry run. If you have any issues, we can discuss, if you think so. Otherwise, I will go to the next. Or if you have any doubt regarding the discussion, I can again discuss. So without any hesitation, without any shyness, you can just ask me. I will be happy to answer. Because at least I can understand that people are with me. Bolo.
No issue, sir.
Huh?
Sir, no issue regarding sorted or unsorted, sir.
Okay. So, should I go to the next?
Yes, sir.
Okay. So, do you know this selection sort, bubble sort? Then I will skip the entire thing, this part. Akash, do you want to say anything? Akash, do you want to say anything?
No, sir.
Okay. If this part, I mean this sorting, searching is
No, sir. No. No.
what? If you say that your sorting, searching part is clear, then I will simply skip the entire portion and directly go to the linked list and all. Or if you say, no, sir, you discuss this part, then I will be happy to discuss whatever you say. Depending on your requirement, I will go through.
So sorting and searching part is clear. You can directly go to linked list.
Okay. Is it okay for everybody? Directly go to the linked list?
Yes, sir.
Okay.
Yes, sir.
Huh? শুভম,
Yes, sir.
হ্যাঁ কি করবো তাহলে শর্টিং সার্চিং পড়াবো না, ডাইরেক্টলি চলে যাবো লিংক লিস্টে? বা পয়েন্ট
সার্চিংটা একটা বেসিক দেখিয়ে দিন, তারপরে লিংক লিস্টে চলে যান।
আচ্ছা, আর পয়েন্টার দেখানোর দরকার আছে? পয়েন্টার ডাইনামিক মেমোরি অ্যালোকেশনস,
পয়েন্টার ডাইনামিক মেমোরি অ্যালোকেশনটা একটু দেখিয়ে দিন, ওটা একটু দরকার আছে।
বলো।
হ্যাঁ, ওটা একটু দরকার আছে স্যার।
ওকে ওকে ওকে। So after selection sort, I had the idea to go for bubble sort. So I think bubble sort is clear. And if you need, I can discuss. That is also fine. Okay. Okay, so I will be going to this chapter, pointer, then dynamic memory allocations, and then we'll be going to the linked list tree. Okay. Can anybody say what is this? What is this?
So NIT Durgapur.
not
Sir,
exactly an
visiting
ID.
card, sir.
Is a visiting card. Visiting card of a person.
Your ID card, sir.
So it is a visiting card of a person named as Animesh Datta. Right? Can you say this is the person? Can we say the visiting card is the person? The answer is of course no. Visiting card is containing the address, maybe the official address or the residential address of a person who resides in this address. Visiting card is not the actual person. Visiting card is not the actual person. Visiting card is containing an address, maybe office address or residential address. Visiting card is containing an address. That address, in that address, somebody is located. That is the definition of visiting card. In the same way, pointer is containing an address where a variable is stored. So if you try to bring the analogy this way, you never forget what is pointer. The way we used to say a visiting card, in the same way we can say pointer. Visiting card is containing the address of a person who reside in that location. In the same way, pointer is containing an address where a variable resides. So typically we can write like this. Typically we can write int x. So x is an integer type variable. X is an integer type variable. We can write x equal to 5. The moment I say like this, we are defining a variable x of type integer which contains a value 5. So the moment I say like this, a box in the memory will be created whose name will be as x, content will be 5. Now we are defining one more variable int star p, that imply p is a pointer variable. Pointer variable means p is a visiting card where you can keep some address. P is the visiting card where you can keep some address. In visiting card, you can keep the address of a person, human being. In int star p, if you define like this way, in p you can contain or you can keep the address of an integer variable. We are writing p is equal to ampersand of x. That is called the address of x. The moment we say x is a variable and we are defining, we are storing some value here. So a memory location will be blocked in main memory. Main memory means the RAM. And each of the location in the main memory RAM will have a definite address. Just like every city in India will have a pin code. Every city has a pin code. Every village has a panchayat. In the same way, every location in the main memory or RAM has an address. It's a numeric value. So when we say we are declaring X as an integer variable and storing 5 in X, so a location will be allocated in the main memory. A location will be allocated in the main memory, and that location has a definite address. It will have a definite address. And what we are doing, we are allocating the address of X to P. Now, if I say the address of this location is (204085), then P will contain the same address, because P is a pointer. P is a pointer which can hold the address of an integer variable. And what we are doing, we are defining an integer variable X which contains the value 5. उसका जो address है, that address we are keeping in P. So here P is something like your visiting card. P is something like your visiting card, which is holding an address. किसका address? जिस address में ये रहता है, जिस address में X used to stay. So P is the visiting card, which is storing an address. In that address, somebody is stored. So visiting card is containing an address. In that address, Onimesh Dotto resides. So every variable you define, every variable, every data structure you define in main memory will be stored in the memory, and that memory location will have an address. Whether it is an integer, whether it is a float, it is a character, whether it is a string, it is an array, it is a structure, whatever element you are defining, whatever variables you are defining must have a definite address in the main memory. And if you can catch that address, that is the pointer of that variable. So here you see in this example, in main, we are defining two variables, char A is a character type variable, B is a character type variable. What we are printing? Printf ampersand P, percentage P, ampersand A, ampersand A. Ampersand A means the address of A, and address of B, address of X. So we are printing address of A and address of B. Even we can keep some values here, maybe X. We can keep, but we are not printing the values of A and B. Rather, we are printing the address of A and B. And mind it, if you write the same program to different machine, two of your friends will have a different result. Because two machines may have different hardware architecture, different memory architecture, or even their memory location, even they have a same computer, same type of computer, same architecture, but the memory allocations are different. So this A and B may be stored in different location to two different computers. And as a result, their address will be different. So you will expect different result after running this program. Here you see. Here we are taking a variable a whose value is this -1, 2, 3, 4. That variable must have an address. This is the address of the variable a. We are defining a variable p of type pointer which can store the address of a. So basically what we are writing in the code, p is equal to ampersand of a. That means p will store the address of a. Address of a is this, so p will store this address. Multiple pointer to a variable. We are storing, both p and q are contains the same address, because the address of a is fixed. The address of a is fixed, and that address is this. Whether you are keeping in p or q, both will be same. Here you see some more example. The main function, we are defining a variable int a. Then we are defining star p, pointer variable. A is assigned with 14. That is, a is assigned with 14. P is ampersand a. And we are printing a and ampersand a. So a will be printed as 14, ampersand a is even instead of that, if you write p, both the result will be same, because p means ampersand a. So p will contain the address of a. Now if we are writing this, what is the meaning of this? It means it is the value of the variable whose address is stored in p. It is the value of the variables whose address is stored in p. That means p में जो address है, उस address में जो variable है, उस variable का value. p में कौन सा, किसका address है? a का address है. p में किसका address है? this address. इस address में जो variable है, a है, उस variable का जो value है 14. So this is typically give you the result 14. So a is 14, p is ampersand a, the address of a, and star p means the value of a. Or we should say this means it is the value of the variable whose address is stored in p. p में जो address है, उस address में जो value है, that value, उस variable का value. That do you want to try with this thing?
Yes, sir.
तुम लोग करना चाहोगे इसको? Is the
Yes,
pointer?
sir.
Bolo. Or do you want to do with your own hand this example? Here we are defining three variable a, b, c of type integer. We are also defining three variable p, q, r, which are of type integer pointer. That means they can store the address of integer. Now we are assigning values. We are assigning values 6 to a, 2 to b, and so a में 6 है, b में 2 है. Now we are writing p is equal to ampersand b. What is the meaning of that? We are storing the address of b in p. Next, q equal to p. And r equal to ampersand c. So r is storing the address of c. Next, we are writing p is equal to ampersand a. That means p is storing the address of a. Earlier p was storing the address of b. Now p is storing the address of a. And ampersand q is 8. Ampersand q means q में पहले जो एड्रेस था b का एड्रेस था, so that address was assigned to q. So उस एड्रेस में जो value, that is 8, we are putting it. So 2 is replaced by 8. Next, what we are changing? Star r is equal to star p. We are replacing the value of this with this. That means r में जो एड्रेस था उस एड्रेस में जो वैल्यू, r में कौन सा एड्रेस था? c का एड्रेस था. c का एड्रेस में जो वैल्यू, so that we are changing. So this way the entire operations has been done. And finally, we are printing ABC. That will be 6, 8, and 20. So basically, finally the assignment is this. So if you print 6 ABC, 6, 8, and 20 will be printed. If you print star p, star q, star r, that will also print the value of a, value of b, value of c. That is ABC. So that's why twice it has been printed. One for ABC, one for star p, star q, star r. Okay. It's a very interesting program. How will you pass the pointer? How will you pass the pointer to a variable? There are two variables, A and B. So first we will tell the problem, then we will be going to the solution of it. So here, with this slide, we will be discussing the problem. Then we will be coming out with the solution by using the pointer. We have two variables, A and B. We have two variables, A and B. A is containing 5 and B is containing 7. We want to swap their values or exchange their values. That means after the operations, B will contain 5 and A will contain 7. So for doing that,